napapansin, mga bulaklak ay magkakawangis, mga dahon ay magkakahugis. Hindi mo ba naitatanong, mundo'y may ayos na sinusundan, sa math ninyo yan malalaman. Halina, sumama na kayo, maglakbay, mag-enjoy, maglaro, tuklasin ang math sa buhay natin, dali na, mag-math na tayo.
What is geometric design? Geometric design is the process of creating or designing objects, structures, or systems using geometric principles and shapes. It involves the use of various geometric elements such as points, lines, curves, angles, and shapes to achieve a desired outcome. Geometric design is utilized in various fields, including architecture, engineering, graphic design, industrial design, and art. The concepts of geometry plays an important role in creating designs. The ideas of balance, repetition, rhythm, pattern, symmetry are some concepts that are associated to designs. The design that appears in paintings, structures, sculpture, ceiling, and textile imprints cannot be separated from these geometry concepts. Other geometric patterns use more complicated shapes with some irregular shapes that we don't have names for. In this lesson, we will emphasize on the appreciation and importance of the geometric design and its artistic and cultural significance. Now, let us learn together the basic concepts of Euclidean geometry. Euclidean geometry, sometimes called the parabolic geometry. It is a geometry that follows a set of proportions that are based on Euclid's 5 postulates. In the next pages, I will show you these 5 postulates by Euclid. The first postulate is the straight line and may be drawn from any point to any other. This postulate can be extended to say that a unique one and only one. Straight line may be drawn between any 2 points. This means that if you have any 2 distinct points, there is exactly one straight line that connects them. Euclid's straight line postulate is commonly used as a foundation principle in geometry, such as constructing geometric shapes. The second postulate of Euclid states that a terminated line or a line segment can be produced indefinitely. In essence, this postulate allows for the extension of a finite straight line continuously in a straight line. It's a foundational concept in geometry that supports the idea of infinitely extending lines, which is crucial for constructing geometric figures and providing various geometric theorems. The third postulate is the circle and can be drawn with any center and any radius. This postulate is fundamental in geometry as it allows the construction of a circle given any center and radius, which is essential for creating geometric figures and solving problems related to circles and arcs. And now we have the fourth postulate, which is all right angles are equal to one another. The purpose of Euclid's fourth postulate is to establish a fundamental property of right angles that is used throughout geometry. This postulate ensures that right angles can be considered equivalent and interchangeable. Now down to the fifth postulate. If a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on the side on which the sum of angles is less than two right angles. By the way, this postulate is also referred as the parallel postulate. This is to establish the behavior of the parallel lines within Euclidean geometry. Plane geometry is the study of figures on two-dimensional surface that is on a plane. It deals in objects that are flat, such as triangles and lines, which can be drawn on a flat piece of paper. Plane geometry is incredibly useful in various fields, such as architecture, engineering, navigation, astronomy, and computer-aided design. Solid geometry is the study of figures on a three-dimensional Euclidean space. It includes the measurement of volumes of various solid figures or three-dimensional figures, such as the pyramids, cylinders, cones, spheres, and prisms. Solid geometry is very useful in computer graphics because it's crucial in 3D modeling and animation, providing the mathematical foundations for rendering objects on screen. The simplest figures in geometry are points, lines, and angles. In the next slide, we'll discuss the characteristic of these geometric terms. The first on the list is the point. The point is a location in space. It has no magnitude, a point has no size, and can be named in a capital letter. And we also have the line. The line extends infinitely in opposite directions. It has length without breadth. 2 points define a unique line. A line can be named using a lowercase letter. To know more about the full information in regards to the definition or description and also the illustrations of the basic geometric terms, I highly recommend you to visit the page 104 up to 105. Geometric shape is generally defined by a set of points and lines that are connected to form a closed figure. Particularly, it can be defined as figures or area closed by a boundary which is created by combining the specific amount of curves, points, and lines. It is very important to recognize and analyze geometric shape because geometric shape are everywhere in our daily lives, from the structure of buildings to the design of everyday objects. Understanding geometry allows us to better navigate and organize our world. The first type of geometric shapes is the two-dimensional geometric shapes. These are closed figures made up of vertices joined together by lines. The example is the triangle. The side opposite to the largest angle is the longest side of the triangle, and the side opposite to the smallest angle is the shortest side of the triangle.
Parallelogram. A quadrilateral that has two pairs of parallel sides, two pairs of opposite angles are congruent, and the consecutive angles are supplementary. Trapezoid. A quadrilateral with exactly one pair of parallel sides. The parallel sides are called bases. A quadrilateral. A trapezoid in which the non-parallel sides, the legs are congruent. Rhombus. All the properties of the parallelogram apply. The ones that matter here are parallel sides, opposite angles are congruent, and consecutive angles are supplementary. All sides are congruent by definitions. The diagonals bisect the angles. The diagonals are perpendicular bisectors of each other. Kite. A quadrilateral in which two disjoints, pairs of consecutive sides, are congruent. Disjoint pairs means that one side can be used in both pairs. Polygons. A polygon is a closed figure where the sides are all line segments. Each side must intersect exactly two other sides, but only at their endpoints. The sides must be non-collinear and have a common endpoint. A polygon is usually named after how many sides it has. A polygon with 9 sides is called engon. Pentagon. A polygon with 5 sides and 5 angles. Hexagon. A polygon with 6 sides and 6 angles. Heptagon. A polygon with 7 sides and 7 angles. Octagon. A polygon with 8 sides and 8 angles. Nonagon. A polygon with 9 sides and 9 angles. Decagon. A polygon with 10 sides and 10 angles. Conix. Circle. A line forming a closed loop, every point on which is a fixed distance from a center point. Ellipse. A regular oval shape traced by a point moving in the plane so that the sum of its distance from two other points, the foci, is constant or resulting when a cone is cut by an oblique plane which does not intersect the base.
Common three-dimensional geometric shapes, or 3D. What are three-dimensional shapes? A three-dimensional shape can be defined as a solid figure or an object or shape that has 3 dimensions: length, width, and height. Every 3D geometric shape occupies some space based on its dimensions. They have volume and can be described using various properties including edges, vertices, and faces. So if you remember 2D, they only have corners and sides, while in 3D, things are a bit different. Like this cube, instead of corners, they have vertices, and if you're only looking at one, we call it a vertex. They also have edges, which are the lines between the vertices, and faces, which are the flat surfaces between the edges. The first common 3D shape is rectangular prism or cuboid. Cuboid is a box-shaped object It has 6 flat faces and all angles are right angles. All of its faces are rectangles, and it is also a prism because it has the same cross-section along a length. Next is triangular prism. Just like cuboid, it has same cross-section along a length. The cross-section of this object is a triangle. Next is a cube. A cube has 6 faces. Each face has 4 edges and is a square. It has 12 edges. It has 8 vertices or corner points, and at each vertex 3 edges meet. It is also one of the Baconic solids. Next in line is a square pyramid. A square pyramid has 5 faces. The 4 side faces are triangles. The base is a square. It has 5 vertices or corner points, and it has 8 edges. Next is a triangular pyramid. A triangular pyramid has 4 faces. The 3 side faces are triangles. The base is also a triangle. It has 4 vertices, 6 edges, and is also a tetrahedron. Next is a sphere. A sphere is perfectly symmetrical. All points on a surface are the same distance from the center. It has no edges or vertices. It has one surface, and it is not a polyhedron. Following is the cylinder. The cylinder has flat base and a flat top. The base is the same as the top. From the base to the top, the shape stays the same. It has one curved side. It is not a polyhedron as it has a curved surface. Next in line is the cone. The cone has circle at one end, a point at the other end, and a curved side. It is not a polyhedron as it has a curved surface. Last but not the least is a torus. A torus can be made by revolving a small circle along a line made by a bigger circle. It has no edges or vertices. It is also not a polyhedron. Generally, these basic 3-dimensional and 2-dimensional geometric shapes are seen in real world. This can be used as basic pattern for an inevitably beautiful wallpaper design, windows and doors in our house, paintings, donuts, glass, towers, pyramids, and etc. Really, it is true that shapes are all around us. Moreover, shapes are also used as symbols that emulate different cultures and beliefs of different people, which will be discussed in the next lessons.